Notice that some of them burn out in like 0.2 of a second. Those are the ones that just go poof and they're gone. And you never see them again. We used to build these things, the ones that use like the little B rockets, right? And they just go off and then they're gone. It's like, where'd it go? I don't know. Yeah, it's like a puff with smoke, right? It's like puff. You never see them again. It's like you spend like hours building them and sanding them, testing them. Puff. Honest to God, we never found them. I don't know if the chutes didn't open or I have no idea, right? Okay, now look at this. I just want you to see this. It says maximum total impulse. Notice that it's giving it to you in Newton seconds. Didn't we learn that? We learned that. I taught that to you. Yes? Okay. And then they've got propellant weight in grams. And from this, we can actually figure out what the exhaust gas velocities are. Yeah? That's kind of cool. Isn't that cool? Yeah. Okay. Now, you want to look out. There's a story I can tell, and I think it's been 7 years, so I can tell this story to you. But my very first year teaching as a physics teacher, I thought I'd teach the kids a little something about rockets. Yes? Are you picturing this? Okay. So my response was to take a very lightweight dynamics cart, go out into the hallway, and there was like an intersection, kind of a hallway type of thing like this, and I set up a very lightweight dynamics carts. They're actually made of extruded aluminum with these very low friction wheels. And they probably had a mass, I think it was about 0.5 kilogram. At top's 0.5 kilogram, right? Now I hooked a D12 engine up to it because I thought, hey, that's a good idea. The biggest engine possible on the lightest weight cart that I can find, yes? Are you picturing this? Okay, so let's do the math here. Force times time is mass change in velocity. Well, force times time all multiplied together, and in fact, to do it right, you actually have to find the area under this graph. You'd have to like integrate that and find the area. They're telling us that it's all added up, all of this force, the average force times all of this time for the D12 is 20, right? So, okay, do we have a problem with this? No problem, right? So 20 Newton seconds is 0.5 times delta V. Now, does anybody want to help me out? What's delta V?
40.
Is it 40? Is 40 meters per second fast? Why, I believe that's about 90 miles per hour. Yeah? Okay, so it's 40 meters per second, right? You know? Okay, so picture this. Did I do that calculation before I tried it? No, I've got a degree in physics. I don't need to do that, right? So I get the kids out. We stand in the hall, and along this side was like a courtyard. This is Breck School, Minneapolis, Minnesota. I've been back there. There's a little courtyard. I believe on this side there's like heaters on this thing. I had the kids sort of stand up next to the windows with their feet off the ground. That's a good safety precaution, don't you think? Yeah, right? And I went out there. I had a big power supply, and I was going to like light them off with electrically, right? And I stuck the D12 engine on there. And the amazing thing was that nobody saw anything that happened because the air immediately filled with this acrid smoke, this sulfurous burning smoke. Our eyes were like, ah, you know. All the kids that had asthma were out in the courtyard going, ah! We're laughing at somebody that has asthma, right? This is terrible, right? You know, okay. And as far as we can tell by just looking at the clues that we had, it went about this far, and then it did something that caused it to burn the ground. We're not sure exactly how it would have done that. And it flew through the air, we think at about waist height, from about here to the end of the hall, and it struck. We could hear it hit the end of the hall, right? And it made a kling sound like a bell ringing, only different, had more of a crunchy sound. And this is a cinder block wall. And it actually poked a hole in that wall. Not all the way through the wall, as the story later became that Murray poked a hole all the way through the wall. The story got better and better because they had to fix that cinder block. Cinder blocks are not all that strong. Like if you carry them around, you'll break one or two. You know what I'm talking about? They're hollow. They're only like this thick, right? If you took a ball peen hammer to a cinder block wall and hit it sharply, you could probably knock a hole in it in a couple seconds, right? Okay, and that's what it did. Was it made a comically small hole, which to repair they had to chip out an entire cinder block, yes? And so people saw the cinder block after it was torn out, and they're like, Murray knocked a hole all the way through to the women's locker room, which happened to be on the other side, right? You know? So the story got better than it really was, but still, it's still a good story, though, isn't it? Yeah, I think so. You know? Okay, so I never did that again until I went to the Indian. Well, okay, I did it with smaller rockets, right? I go to the Indian school. right? This is like Indian, like as a Native American, right? Okay, and I decided to do the same thing, only we're doing it outside. This is, by the way, a very, very bad idea, right? I'm doing this outside, and we've got this cart, and the kids even put like wings on it, that's going to keep it on the ground or something like that, right? Right? And I did not have a fancy electric power supply. All I had was dynamite fuse, right? Yeah? So instead of like lighting it with like a 3, 2, 1, turn on the switch, I just lit the fuse, and then we went back inside. There's like in Minnesota, it's so cold outside that they have these little things you sit in to wait for the bus to protect you from the wind chill. So they have this one had clear plastic panels. It was like a little bunker up against the school building. We could sit in there and watch, but we were protected, kind of a thing. Are you picturing this? Right? So I light the fuse, the dynamite fuse, right? We all run inside there. We've got 30 seconds, 40 seconds or so. It burns about an inch a second. You can just measure it out, right? Okay. And so we're all sitting in there watching, right? Well, swear to God, a brand new police patrol or cruiser comes into the parking lot, parks right in front of the damn thing. I go to go out. The fuse is getting damn short, right? Right? Okay. And I'm going out there, and it's like it's too late. The thing goes off. It's headed right for the car. Okay. Then it does a crazy jiggity thing. It does a little thing where it kind of goes, choom, and it shoots up in the air, and then it does a little crazy uncontrolled tumble in the air above the car. Right? Yeah. Lands on the other side of the car. Are you picturing this? Never touches the car. Doesn't burn anything on the car, right? And I'm just like, right? Okay. The officer gets out of the car, just walks straight toward me. He's got like sunglasses on, just stony face, just like, and I'm like, oh, cool. I'm just like, take me away, right? And by the way, it was not that uncommon for a police cruiser to pull into the school, because it was not exactly Dances with Wolves. It was like, what gang are you in, and can we all get along, kind of a thing, right? Okay. He walks right by me. He says hi, walks right by me. As far as I can tell, what happened was he pulled in. He had paperwork to look at. He was looking at the paperwork, right? And he had the windows shut. It's Minnesota. It's 20 below out, right? The windows are shut. He did not even hear it. It went right over his car. He didn't even hear it or see it, I think. Is that right? I mean, he would have said something. Don't you think he would have? I mean, I didn't bring it up. I go, hey, did you see that rocket that went over your car? It was great. It went like this. I don't know. He was, honest to God, he looked pissed. He was not. Okay, here is a liquid fuel engine. These guys have delta V's, in other words, exhaust gas velocities of 2,000 meters per second. This is obviously if you're trying to go to the moon or something like that. Better bring in a liquid fuel rocket. Now, for the space shuttle, the fuel was hydrogen. The oxidizer was oxygen. Okay. For the Saturn V rocket, for that guy, only it was bigger. Okay. The fuel was kerosene, and the oxidizer was liquid oxygen. Okay. Liquid oxygen, the most pure form of oxygen, right? And it's a cryogenic gas. It's very, very cold, right? And then the question is, why kerosene? Kerosene doesn't explode. Well, no, kerosene doesn't explode when there's like normal air, but with pure oxygen, kerosene explodes. Yeah? Things that just burn in air are going to explode when there's pure oxygen on them, right? And then these pumps here pump those fuel in there. Those pumps know stoichiometry. They know exactly how much of this to mix with how much of that, so that there's nothing left over. All that comes out of here is carbon dioxide, water, heat, right? Like you learned in chemistry. Okay. Now, I got this from Microsoft Encarta. When I read their description of rocket propulsion, they gave an interesting explanation of it, which I will repeat. Okay. They said that the explosion in here pushes in all directions. Doesn't that make sense that an explosion would push in all directions? Yes? Now, some of the explosion pushes this way, but some of it also pushes that way, and those forces cancel, yes? And some of the explosion pushes this way on the chamber, but some of it also pushes back, and those forces cancel, yes? But the part of the force that pushes upward on the top of the chamber, there's nothing to push on, is there? So that force is unbalanced. Isn't that an interesting way to explain it? That there's an unbalanced upward force. So, for example, if there's a pressure of 1,000 pounds per square inch in there, and this nozzle is 5 square inches, then you've got a thrust of 5,000 pounds. Yeah? 1,000 pounds for 5 square inches is 5,000 pounds, right? So that's an interesting way to explain it, I think. Here is a great big NASA liquid fueled rocket taking off, and I believe what it's doing. I think this is actually the Explorer launch. They're launching the Explorer spacecraft, which has actually left the solar